If I used all my fingers and all my toes and maybe even most of the hairs on my head, I don't think I could count up to the number of protocols, standards, and regulations that support communication networks. The wiring has standards, the connectors have standards, the patch panels have standards. Add the switches and the protocols and the applications and you start to see what I mean. All aspects of communication are defined in one way or another. And this is important because if they weren't, trying to get two devices to communicate would be impossible. Some protocols, such as cabling specifications, work just as well for cables carrying data as they do for cables carrying voice. Then again, many applications don't cross over between the two communication technologies, and separate protocols are required for each. Voice standards and protocols were designed to support voice, the whole voice, and nothing but the voice between phones and phone switches. From the very core of their design, they were built to support reliability, quality of service, and limited delay. On the other hand, data standards were designed just to meet the needs of data traffic. Data requirements include redundancy and error checking and minimum loss. Timing issues were never really a consideration for data, as data is not affected by how long it takes to get from one place to another. Many of us have experienced this when downloading a large file over a slow link. You may care how fast it goes, but the data itself doesn't. It will all get there eventually, whether it downloads very quickly or very slowly. Since voice and data protocols are designed differently, a new generation of protocols is required to operate happily in a converged environment. Some existing protocols like IP will work fine, while some others may need to be modified. Some protocols simply won't work at all in a converged network, so they'll eventually become obsolete. Even with the existing protocols that can work or be modified to support convergence, some brand new protocols need to be created to make convergence successful. It's interesting to note that ATM was designed as a convergence protocol, with the ability to offer different levels of service to the different traffic types. Although the technical merits of ATM are quite impressive, it has failed to achieve acceptance in many corporate networks due to its complexity and its high cost of implementation.